So we spent the last few days looking at and probability. What's the probability that this event and this event will occur? Now we're getting into or probability. What's the chance that this or this will happen? Well, there's two different types of or probability, just like there's two different types of and probability. There's events that are mutually exclusive. They cannot happen at the same time. So for example, if you're choosing cards from a deck, what's the probability of choosing an even number or a face card? That can't happen at the same time. If you pull one card out of the deck, it cannot be both an even number and a card with a face on it. Then there's what are called inclusive events, and these are events that can happen at the same time. So again, going back to our deck of cards, the probability of choosing a card that's a red card or a 5. You can pull a red 5 out of the deck. There's two of them. So what you will do in that case is you'll add the probability of the red cards plus the probability of 5s, and then subtract off the probability that you double counted. There's two cards that fell into the red category and they fell into the 5 category, so you counted them twice, but they're not in the deck twice, so you have to subtract off that double counting. So we're starting off with calculating probability of pulling cards from a deck. An even or a face card. So think about, can that happen at the same time? No, that was just on the example at the last page. So these would be mutually exclusive events, and we would simply add their probabilities together. In a deck of cards, there's 2, 4, 6, 8, and 10. So there's 5 even numbers in each suit times 4 suits gives us a total of 20 even numbers out of the 52 cards in the deck. For face cards, we have Jack, Queen, and King. So 3 cards in each suit times the 4 suits gives us 12 face cards out of 52. Adding those together, we get a total of 32 cards that are even or a face. And then we'll simplify. We'll divide each of them by 4, and we get 8/13. Second example, what's the probability that we get a club or a heart? Can that happen at the same time? No, those are two different suits, so these would be mutually exclusive events. There are 13 clubs out of the 52 cards and 13 hearts out of the 52 cards for a total of 26 cards out of 52, which gives us half the deck because we're talking about 2 suits. And finally, we have the probability of a 3 or an ace. Can you pull one card out of a deck that is both a 3 and an ace? Nope, so these are mutually exclusive again. We have 4 3s out of the 52 cards, 1 3 in each suit, and we have 4 aces, 1 ace in each suit, for a total of 8 out of 52. Simplifying and dividing them each by 4, we get 2 out of 13. Next, we're looking at inclusive events that can happen at the same time. So there are reds and 5s. This was our example on the first page again. In a deck of cards, there are 26 of them that are red because half of the cards are either a heart or a diamond. Those are the 2 red suits. There are 4 5s, 1 in each suit. And as we said before, there are 2 cards that are red and 5. So we have to subtract off those cards because they don't exist twice. So we have a total of 30 minus 2 is 28 out of 52. Dividing them each by 4, we get 7/13. What's the probability that we get a spade or a face card? That can happen at the same time. There are 13 spades out of 52 cards in the deck. We counted face cards on the last one, 3 in each suit for a total of 12 face cards. So now we need to think about how many cards we counted twice. How many cards are a face card and a spade? Well, that would be 3. There's the Jack, Queen, and King of Spades. So we subtract off those 3 cards that we double counted. So we have 25 minus 3 is 22 out of 52. Dividing them each by 2, we get 11/26. Next example, can we get a card that is both a diamond and less than 4? Yes, so this is inclusive, so we will subtract off the probability that they can both happen. There are 13 diamonds, 13 cards in each suit. The numbers that are less than 4 are 2 and 3. There is not a number 1 in the deck, and an ace is not a number. Depending on the game, ace can be high or low, so we will not count that in our probability. So there are 4 2s and 4 3s for a total of 8 out of 52. And then we will subtract off the chance that we can get a diamond and a number less than 4. So there are 2 cards that are diamonds and less than 4, the 2 of diamonds and the 3 of diamonds. So when we subtract off that 2 out of 52, we get 21 minus 2 is 19 out of 52, and that does not simplify. Here are your you try questions. Decide if they can happen at the same time or not. And if they can, make sure you subtract off that extra probability.